problem 5 asks us to differentiate the following functions. So the first one is f of x equals 23 divided by cosecant x. So as the problem is written out, it would be a quotient rule, but remember, that's the most complicated of all the differentiation rules, so if we can rewrite the problem, we want to. And since every trig function has a reciprocal identity, I can rewrite this as 23 sine x. So now I can differentiate it directly. So f prime of x equals 23 cosine x, because the derivative of sine is cosine. Part B, we have the first term here is something with an x times something with an x. So this part of the problem is going to require a product rule. So the first term is x to the negative 3, and the derivative of that is negative 3x to the negative 4. The second term is tangent x, and the derivative of tangent x is secant squared x. So the product rule says derivative of the first times the second plus the first times the derivative of the second. So when I write my y prime, I'm going to follow this rule and get negative 3x to the negative 4 times tangent x plus x to the negative 3 times secant squared x. So this is only the derivative of this part. Then, to get the derivative of cosine, we just do that directly. So the derivative of cosine is negative sine. So now we're done. Part C, we have a quotient rule. So the derivative, or excuse me, the numerator, right, is sine x. The denominator is 2 plus tangent x. The derivative of the numerator is cosine x, and the derivative of the denominator is just secant squared x, because the derivative of 2 is 0, then plus the derivative of this, so we just get secant squared. So the quotient rule says derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator all over the denominator squared. So when I apply the quotient rule, following my guidelines here, cosine x times 2 plus tangent x minus sine x times secant squared x all over the denominator squared. Part D is a little bit of a beast, okay? So what we have going on here is we definitely have a product rule, right? You want to kind of zoom out and think macro here. We have a product rule, so we have this term times this term, but when we go to do the derivative of the second part, we have to deal with another quotient rule. So I'm going to name these functions f and g, just so we can keep up. So the first function, f, is x minus x to the fourth. And the derivative of that is 1 minus 4x cubed. But the denominator is this entire quotient. So to get the derivative of this quotient, right, I have to do the quotient rule. So it's the derivative of the numerator, which is cosine x, times the denominator, minus the numerator times the derivative of the denominator. And the derivative of cotangent is negative cosecant squared x, plus the derivative of 12 is just 0. And then all of this goes over the denominator squared. So now I have to do the product rule on all of this. So the product rule says, right, derivative of the first, so the derivative f prime is 1 minus 4x cubed times the second piece, which is sine of x over cotangent x plus 12. So there's our f prime g. And I'm not going to have quite enough room to write it all here, so I'm just going to carry it down to the next. So the product rule, right, is plus f, which is x minus x to the fourth, times g prime. And g prime is all of this. So cosine x times cotangent x plus 12 minus sine x times negative cosecant squared x all over cotangent x plus 12 quantity squared, and this is our g prime. So overall we had the product rule, so f prime g times f, or excuse me, plus f times g prime. So all of this is that derivative. So we can combine these rules into one derivative.